I worked on when I was your age. This is a GCMS, Gas Chromatography Mass Spectrophotometer. Okay. And this is the company that makes them, Agilent. And this is the 7000B quadrupole GCMS MS system. This is a tandem, meaning the MS, the mass spectrophotometers are tandem, they operate together in tandem. And this is what a mass spectrophotometer is: a perpendicular electric and magnetic field. So the detector, what happens is after you separate components down the chromatography column, you have two of these MS systems, and let's say this is positively charged, these two are negatively charged, and you use this to guide. Once you separate a component, you use your detector to guide this down. You actually detect it with two tandem systems of this. And this is one other one. It's nice one. This is a chromatography system. In a chromatography system, normally has a carrier gas. It normally has something to push components down a column. This is a column. This is a column it's very thin. It has some silicon gel or some silicon particles inside of it. And we've already talked about maybe a height of a theoretical plate. The longer the column or the thinner the column, the more height of theoretical plates it will have. And there'll be some detector and some readout. And this is what a gas chromatography apparatus looks like. And what is chromatography? Well, I introduced this, you saw this before in middle school. In middle school class, this might be your stationary phase. So you might give somebody in the 8th grade this stationary phase, and you might tell them that ink is DNA. And they'll separate the components of, say this is black ink, it'll separate into components of a beige component, a tan component, and a bluish component. And I sent you guys, I tried to email you guys a videotape. Chromatography is a set of laboratory techniques for the separation of mixtures. It involves passing a mixture dissolved in a mobile phase through a stationary phase. In middle school, I can use alcohol. I use isopropyl alcohol as a mobile phase. And it like to be measured. And I'll tell a middle school student that the ink is DNA. And you've already seen something called the partition coefficient, right, from your past experiment. And this is a chromatogram. When I was your age, I did a chromatogram of a homologous series. And these might be two components. This might be hexane, and this might be octane. And the coffee paper can be considered a stationary phase. Again, isopropyl alcohol will be a good mobile phase, and the ink can be DNA. So the coffee paper will be a molecular sieve. Okay, this is your column. This is what a column looks like in a modern gas chromatogram. It's molecular sieve. The ink will be DNA. You tell them they're doing some DNA analysis. And alcohol is a good mobile phase. Why? Because alcohol has an OH group, it's a polar group, and it also has a hydrocarbon group. Okay, so I had to take this very boring class called chemical separations, and it's a course that stresses the theory and application of chromatography. There's about 550,000 types of chromatography, and these are some of the things that you learn. Splitless injection, sample injection. These are the type of detectors you could use in chromatography. Flame ionization or electron capture. in your text there were two tables, and this is basically the theory. I'll have two components. Say you'll be doing different aspirins, ibuprofen, caffeine, and what will happen is if I have two components A and B. Let's say I have bufferin and anisine, okay, and they go in and out. First I crush them and put them in a mobile phase, and they'll go into the solid phase. They go into the solid phase, and they'll go back to the mobile phase. And depending on the polarity or the molecular weight of the aspirin, of the molecules, the size, polarity, hydrogen bonding ability of the actual molecules, the polarity H bonding in the stationary phase, and the polarity H bonding ability of the mobile phase. These molecules will go in and out, the mobile phase, stationary phase.